طيب, okay. بسم الله الرحمن الرحيم. So this is the first part 0 in the book. And this part talks about introduction, including some basic concepts and definitions related to computer security in general and network security in particular. The slides are provided by the book, except that be aware that I modified the slides significantly in some places. So the general rule is anything that we discuss in class, even if it's not in the original slides of the book, you are requested to know it, right? And on the other side, if we're not covering a specific part of the book, you are not requested to know it. At the end, in the exam, it includes everything that we discussed in class, even if there are some minor changes to the book, okay? Okay, so again, in this chapter, we are going to discuss some basic concepts, including what computer security in general means, what network security means, what security mechanism means, what security services means, and some other, what attacks, attack model, attack trees, things like that. So these are fundamental definitions that we need to agree on and be able to distinguish and identify the differences between them so that we can have some ground, foundation based on which we can talk about all the protocols or security protocols after this. Of course, before the widespread of the digital content and the internet and so on, the only way for us to secure anything was to lock it physically in drawers or safe or something like this. This was the only way for us to secure anything valuable, of course. By the proliferation of the internet and the digital era, this concept has transitioned into trying to develop some automated tools, cyber tools that will achieve the security objective using different mechanisms and services, as we will talk about. Another major change that affected security is the introduction of the distributed systems, of course. Securing a single machine is different from securing distributed systems. The nodes or the participants of these systems, they have to be able to communicate with each other. So not only do we need to secure information within a machine, like for example, a stored data, okay? So the mechanisms and tools that you will use to secure a data storage, for example, on a cloud or a centralized database, that's different from securing information while they are being transmitted. Okay? So securing data and information while it's being transmitted requires different mentality. Okay? So with the digital content, we started to have automated tools to secure data while they are being stored, and then later on, we started to think about how we can conceal and hide information while it's being transmitted. So computer security, which is the big umbrella, so computer security is the generic name for the collection of tools designed to protect data and stop hackers. And that's regardless whether this data is stored or communicated. So this is the big umbrella. Okay, so computer security is the big umbrella. Okay, so we talk about how to protect data and systems, okay, from being attacked. Whether this data is stored, transmitted, anything. Whether this data is in any format, whether it's video, audio, things like that, anything, or identity of the person, whatever, regardless of what this data represents and regardless of where this data is, okay? So that's computer security in general. Internet security or network security, okay, talks about how to secure data, okay, and systems while the information is being transmitted. Okay, so when it comes to internet here with lowercase I, this means internet with lowercase I. It means interconnection of WANs and LANs in general. Okay, which could be private network, public network, whatever. Okay, because internet in general is public. Okay, but when we say internet with lower I, this means that we're talking about any interconnection of networks or LANs and WANs. Okay, so this is of course the main focus of this course is to try to secure data and information while it's being transmitted from one system or one node to another. Of course, there is another part of computer security, which is information security, which covers mainly how to secure stored data, how to secure code that runs on a machine or a single machine. Okay, how to secure that type of data on one single machine. But it does not focus much on securing data while it's being transmitted across different distributed systems. واضح كده؟ Okay.
What's the difference between information security and network security? Network would be security of the channel.
Right.
Information would be just the data itself, or
the data stored on so the data, the data which is stored on one single machine. So it focuses مثلا on trojans, on viruses, things like that, which is but once it interacts or it involves interaction between multiple machines by transmitting data or information from one machine to another, that's where network security kicks in and provides you with some protocols and mechanisms that will make sure while the data is being transmitted, it's secure. And we're going to talk about the major pillars and fundamental requirements for how to secure data while it's being transmitted. So, of course, NIST is one of the standard bodies when it comes to security in general. There are some other organizations which we will talk about, including ITUT, Internet Telecommunication Union, and also ISOC. So these are organizations. ISOC اللي هي Ietf. Ietf, some of you are familiar with Ietf from computer networks because this is the main organization that's concerned with developing standards of the TCP/IP and internet stack. So these are major organizations that focus on developing standards for security systems in general. So NIST, they have a subgroup. It's called IFIP or FIPS. Sorry, FIPS. اسمها FIPS 199. So FIPS, they have a recommendation document, which is you don't have to memorize that. The 199, in that recommendation document, they provide some basic definitions of what security means and what other basic concepts mean. So they define security as or computer security in general, as the protection afforded to an automated information system in order to attain applicable objectives. Sometimes they call them objectives, they call them minimum requirements or fundamental requirements, but these are very important objectives that at least they should be achieved in any security system, which are of course, the integrity, availability, and confidentiality. They call them the CIA triad, or the three pillars of any security system. We'll talk about them over and over. So these are the fundamental objectives that have to be achieved in order for your system to be protected against any attacks. ماشي? And this, go ahead.
Isn't it that it's actually standard to define how the system protects itself, not how it secures what you do with it?
So again?
Isn't it that FIPS as a standard defines how a system is supposed to protect itself?
Of course.
Rather than protecting what you do with it.
Yeah, so of course the FIPS, they have developed many standard documents other than this one. And this is the 199. This one was like an introductory kind of recommendation document that will give you some common foundation. So these are the terms that we are going to use in other standards. So if we say
FIPS generally, the goal of its series
right.
is actually targeting to provide guidance how to develop systems that can protect itself.
Yes, of course. FIPS, by the way, is a subgroup under NIST. So FIPS refers to a subgroup under NIST which focuses on developing standards for security systems. So they develop many standards. They provide documents that details or provides the details for many security mechanisms and services and so on and so forth, right? But this document in particular was a fundamental document that lays out some basic definitions, and of course it has some other things which we will cover as we go through. But this is the main definition of computer security from the perspective of the FIPS group or FIPS subgroup as part of NIST. What we would need to focus on is to understand what this pillar means. اللي هي الايه؟ Confidentiality, integrity, and availability. Because these are the fundamental pillars of any security system. And we will take these as a foundation and we'll build on top of them. We will add to them. When I say pillars, okay, a house is not just a pillar. It's not just 3 pillars and that's it. Of course, the house has so many things, so many other things. So just by having these pillars in security system, it doesn't mean that you are secure against all types of attacks. That's not enough. Okay, you need to have some other things. And you need to have many other services and mechanisms other than these in order to secure your system. So this is what we call CIA triad. Confidentiality, integrity, and availability. By, of course, confidentiality here, we refer to the information concealment. How can we hide the information, okay, during transmission? Okay, this is the objective. This is the main objective. Okay, how we will do this? This requires more than one mechanism that we need to have, and not as you just think, just by encryption and that's it. No, you need other things. Encryption may not be enough to have confidentiality, and we will see that. Okay. So confidentiality refers to the information concealment, okay, in general. Integrity refers to protecting data from being altered, okay? So for example, I can have encryption and the information is hidden, okay? But when you send it over a wire or wireless channel, I can just embed anything inside in the middle of this information. So in many applications, just by doing this, the data loses its credentials or its integrity. Okay, the data becomes unusable. Okay, so just by the fact that the data or the fact that you have confidentiality, it doesn't mean that this is enough. So integrity is also another very important pillar that you need to have. So you have confidentiality and you have integrity. So somehow, if your data is altered, now you need to have the measures to detect that this data is altered. Okay? If you detect that this data is altered, at least this is good news, because you should not use this data as it's modified, because it's not valid anymore. Okay? Of course, there are some mechanisms that can help you to even correct and know exactly what modification has been introduced to the data, and therefore you can reproduce the original data. So that's another step. That's not necessarily simple to do. It requires very special mechanism. Availability here talks about the ability of you to access the data, okay, in a timely manner and in reliable manner all the time. In other words, to protect the data from any denial of service. Like for example, I use Blackboard. Okay, availability here means that whenever I log on to Blackboard using my legitimate credentials, I should be able to get Blackboard working. Okay, this is what availability means. If it's down, this means that availability of this type of service is affected negatively. Okay, so availability here means the ability to access data and systems and services in a timely and reliable manner. Okay, and to be protected against denial of service. Denial of service, we'll talk about it later, of course, in details. Denial of service معناه ايه? Somehow, I use my legitimate credentials, and it tells me system is down, or it tells me your user ID and password is not correct, even though they are. Okay, so this is denial of service. Of course, that can be caused by attacks. We'll talk about that. That can be caused by attacks, denial of service attack. There is a specific type of attack called denial of service attack. Many of you could have some idea about it. So, in details, confidentiality here focuses on data confidentiality in general, and by data here I mean any type of data. Okay, could be a video, could be audio, it could be text, could be anything. Privacy focuses on identity of individuals. So when it comes to privacy, okay, we refer to a specific type of data which represents individual identity. Okay, for example, my name, my Qatari ID, my bank account number, things like that. So this is private information. So in many, well.
So just for the terminology wise for the course, does it open and course use data confidentiality and information confidentiality interchangeably, or distinct between data and information?
That's a good question. For the purpose of this course, when we talk about data and information, they are interchangeably used in many ways. And, so you can consider them the same. I know that in some other courses, maybe. Yes, but I know for other courses, like for information security, when we say information and when we say data, they mean different things. So information is usually the observable information from the data. So that the data could be like raw data, but whatever information you can extract from it, that's what we mean by information. For us in this course, we don't distinguish between the two pretty much. They are the same. Yeah, it's pretty much data, yes. And we don't really talk about processing mechanisms that will transfer data into information and so on. It's not the main focus of this course. But what concerns us here is that data confidentiality is different from privacy, slightly different from privacy. So when we talk about privacy here, we focus on individual or person's identity. Okay? So for example, in applications like in health applications, I don't really have to secure the data itself. Sometimes, if I need to transfer, for example, patient record, okay, patient record could include what? It includes some information related to the patient, like for example, his name, his Qatari ID, his health ID, and so on and so forth. That's the identity of the person. And what his ECG is, what his EEG is, what is the blood test, things like that. In many applications, I don't really need to secure the actual raw data itself, because if you look at the EEG on its own, it means nothing to you, right? You see some signal, it doesn't mean anything to you. What I don't want you to do is to correlate that this EEG is for that person. So here, privacy is critical. Data confidentiality, it depends. But privacy is really critical in any system. So hiding the identity of people is of high importance. Hiding the data, well, depends on the application. Some data doesn't need to be, confidential. Okay. But of course, when it comes to integrity, there's no specific difference, because integrity here talks about protection of the data from being altered, from being modified. Okay, so if you modify EEG signal, that's a big deal, right? It's a big deal, of course, because this person seems to have a normal EEG signal that says that this person is normal. By just modification, this person has like a big, critical condition, right? And that, does not allow the doctors and physicians to take decisions accurately, right? So integrity, when it comes to integrity, we don't distinguish it by being like normal data or identity of a person. We don't distinguish it this way. By integrity here, we need data integrity, which includes everything, includes all types of data, including person identity, and system integrity. By system integrity here means that the system performs its intended function in an unimpaired way. Like, for example, if you have a big system and one entity or one server is compromised, okay, that's a system integrity issue. Because just by having this server or this node compromised, it affects the whole function of the system. So that's what we refer to as system integrity. So anything that modifies a data or system such that it affects the function, okay, of that application or that system, that's what we refer to as integrity or lack of integrity. So this means that this data has no integrity, or this system has no integrity. Okay? Availability here, as we said, assures that the system promptly and service is not denied to authorized use. Of course, it should be denied to illegitimate users. That's for sure. But if I have the proper credentials, if I have the authority to access the system, I should not be denied. Okay, and by the way, availability is one of the most difficult things that you can have in any system. You do not have a system with 100% availability. There's no such system on earth. Even Google and Apple, they have some interruption to their services at any point of time, right? So there's no such system that has 100% availability. Okay? But of course, you should have, a higher level of availability, over 90%. So that's sometimes measured throughout the year. So you calculate, like for example, throughout the year, how much time the system was down, or this service was down. So that gives you that, the availability is 99%, availability is 60%, and so on. Okay? The availability is also one of the things that attackers, they actually work on it badly, because especially with the services that we have nowadays, it's very easy to compromise, and we'll talk about this, compromise many millions of small machines and laptops on the internet, right? Sometimes, I'm not sure if some of you have noticed it, sometimes just by connecting your laptop to the internet, after some time you feel like the performance is slowing. And or you feel that somehow there is some kind of intrusion, or your laptop is compromised somehow. And the thing is, sometimes attackers, they use millions of these devices to, to perform some illegitimate requests to a certain system to bring it down. Yeah, so this is what we call denial of service attacks. Actually, I'm not sure if I have, yeah, I think I have it here. There are some websites on the internet that gives you like a visual map of, yes, in real time, of what kind of attack happens and what is the attack origin and what is the attack, what it's attacking. So you see, like, for example, some attackers in China are attacking, like, for example, UAE or something. So you see it in real time.
What's the point of having denial of service attacks to normal people like this?
Normally?
Normal people like this, why do they do DOS?
No, for normal people like us, we need to be educated about the denial of service, but why attackers would do that for different objectives. Sometimes they do some ransom attacks, so they bring, yes, ransom attacks. Sometimes they do it for political reasons, and we had of course many of these as far as we know. So the blockade was initiated with some of these attacks. So for different purposes. In fact, this is one of the easiest attacks. So you can just compromise many laptops and machines on the internet and use them as soldiers for you. So you use them to attack a certain system. And you don't know that your laptop or your machine is compromised. Okay? And for anyone to protect the system against denial of service attack is very difficult, because how can you compete with millions of devices trying to send you some illegitimate request? The time that you will use to process this request until you detect that this is illegitimate request, assuming that the detection is possible, only by the time, given some millions of these requests, you can easily, cause the system to be down. So denial of service attacks are, the trickiest types of attacks that you can protect against. So you need the minimum amount of processing to detect that this request is actually illegitimate. And even with this, you have millions of these attacks, and it slows down the system.
There are infrastructure put in place that can also, you can put your infrastructure behind infrastructure that's designed.
Right. So the least, even if it's possible, very high cost. So you need to have significant infrastructure just to target denial of service. So you have to account for denial of service attacks when you build your cloud facility or when you build your system. So you need to provision for that. So it increases, of course, it raises the cost of your system. All right, so this is what we had in that FIPS 199. So it talks about these definitions, the pillars, and so the ITU T, they provided another recommendation document which is called X800. Again, it kind of aligns with the recommendation document law by FIPS 199, and it adds more to it. It adds more services and basic definitions on top of the three pillars we talked about: confidentiality, integrity, and availability. It talks about authenticity, and it talks about accountability. And those are equally important, really, when it comes to security systems. So authenticity here talks about the fact that we have to make sure that the person or the individual who is accessing this data or this service is really the person who says or she says he is or she is. Okay? We need to make sure that if Amr is accessing this data, that it's really Amr and not someone else. Okay? So we need to ensure the identity of the person who is trying to access that data or that system. So that could be done by, again, this is the service that we need to, the security service that we need to provide in the system. And this could be facilitated by one or more mechanisms, as we will see. For example, we need to have authentication by using مثلا user credentials. What is the other types of ensuring user identity or ensuring user authentication? Certificates, right? We could use certificates. In some cases, we use some physical tokens, right? So these are ways for us, these are the mechanisms that can allow us to provide the security service to make sure that the person who's accessing this system is really the person who says he is, and not anyone else, okay? Accountability is a very interesting topic, and by the way, it's not addressed in the literature and in research compared to other services and pillars. Accountability here talks about the fact that when a problem happens, I can trace it back to who did it. Okay? And when I trace it back to the person who did it, this person cannot deny and say, no, I didn't do it. Okay? This is very important because no matter what security services we're going to have, we are going to be faced with attacks. Successful attacks, I mean. Okay? So there's no such system that's protected 100%. So you are going to have successful attacks. So at least when that happens, you need to be able to trace it back, okay? And you need to be able to ensure who did it, okay? So that you can take some measures against this person. That's what we refer to as forensics. So this is information forensics. بالعربي اسمها البحث الجنائي. اسمه البحث الجنائي. Okay? طيب, what mechanisms we need to have? Many. So we need to have some logs. We need to have sometimes security labels in the files, things like that will allow us to if there is any attack, we can use logs, we can use this mechanism to trace back who did it and identify that person. Okay? If some of you know non-repudiation is part of this. Okay? It's part of accountability. Non-repudiation is the fact that if you send any data, okay, you cannot later on deny that you have sent this data. Okay? It's similar to when you submit مثلا a transfer request to the bank. So they give you a form and you sign it. Later on you say, I did not do that transaction. No, you did it. This is your signature. Okay? So signature is one of the mechanisms for us, or certificates, is one of the mechanisms for us that we ensure that you was the one who did this and not anybody else. Okay? So we can trace back who did it and we can take measures against it.
There are also implementations, especially when it comes to the accountability, we rely on the logs. So to assure that logs that are created by the system arrive intact to the, let's say, security operations center, same or
right.
There are implementation even of blockchain where
right.
you assure that it wasn't modified either on the host or in transport to the same and vice versa.
You mean the logs themselves? Okay. I see. You know what? The logs, they can be maintained on files, they can be maintained in centralized databases, or they can be maintained in distributed databases, like blockchain. Okay? So blockchain is a type of distributed databases that, again, ensures that that this data is immutable, they say. It's immutable, or not altered, not modified. So blockchain is really one of the concepts or applications that allow you to do that. But in my opinion, accountability is one of the areas that is not highly addressed like other types of services. Yeah, eh? Maybe that's why. Yes, maybe that's why. But it's very key. It's very key. It's really key. And by the way, we have been approached by the Ministry of Interior many times about there are different departments, and one of the biggest departments in the Ministry of Interior is the forensics department, and they look a lot at these things. So anyway, security attack, again, we are still in the ITU X800 document now. I'm just trying to give you a perspective. So this document defines the Open System Interconnect Security Architecture, or OSI, is also one of the subgroups in ITU, and they focus also on security architectures and standards. And in the X800 document, they again they put some definitions. So what security attack means? Security attack is any action. Any action. By any action here, I mean any like steps, whether physical steps or programmatic steps or script, program, anything. Okay, that compromises the security of information owned by individual or organization. So that's it. That's an attack. Successful attack, yeah. Hopefully, the attack, well, you can perform an attack, but it's not successful. It is, yes, yeah. We're going to talk about what attack service means later on. Security mechanism is the process or the procedure that is designed to deter or to prevent or to recover from a security attack. So any kind of process or a procedure by procedure or process here, I mean, it could be like a policy. The rules for passwords is this. Well, this is designed to protect the system against illegitimate attack or illegitimate access, right? So that's a security mechanism. Just by defining a policy, it's considered a mechanism. Okay? Security service is actually the processing or communication service or a protocol. The protocol that uses these mechanisms to provide a security for the entire system, a specific type of security. For example, to provide confidentiality, to provide integrity, to provide availability, to provide authenticity, and so on. Okay? So this is what we call. So in other words, if we talk in perspective of the course material and the parts that we talked about, this we are going to focus in part one of the course. We are going to focus on security mechanisms. So we're going to talk about cryptographic mechanisms, symmetric, public key, and so on, and how we provide data encryption, decryption, things like that. What are the properties of each disk, triple disk, RC4, things like that. So these are all a mechanism that allows you to provide confidentiality. Not necessarily enough, but it's one of the mechanisms. Because as we will see, just by encryption, it's not, in many systems, especially in networks, it may not be enough to provide confidentiality. There are some other ingredients that have to work hand in hand with encryption to facilitate or to provide confidentiality. Okay? So that's and this is, of course, part 2 and 3 actually. Part 2 and 3, where we will talk about the protocols, okay, the different protocols, how they can use one or more mechanisms to provide confidentiality. Okay? So for example, TLS in the transport layer, that provides a security service, right? So how does TLS use the mechanisms that we have studied in part 1, maybe one of them, maybe 2, maybe 3, collectively, to provide confidentiality. Okay? And so on. What is the, we will study مثلا some hashing mechanism. That's the mechanism, hashing mechanisms, right? How does TLS use the hashing mechanisms to provide integrity? Okay, that's the service that uses one or more of these mechanisms to provide a security service. واضح كده؟ Any questions? Feel free to interrupt. Okay. So security attacks are classified, as we all know, attacks are passive attacks or active attacks. Passive attacks are more often than not, they have the objective of active attacks later on. يعني it doesn't make any sense that I will eavesdrop on communication to see what these people are communicating. طبعا in many of the security books and systems, you will see Alice and Bob everywhere, right? So Alice and Bob. Okay, so there is Darth, or sometimes they call it Eve. It's eavesdropping on the communication. That's a passive attack. So it's kind of observing. Okay, it's observing the communication between Alice and Bob. This is a passive attack. Active attack is to use whatever information I extracted from the passive attack in order to provide active attack. Okay, active attack. For example, man-in-the-middle attack. So I tell Bob that I'm Alice, and I tell Alice that I'm Bob. And Alice seemingly thinks that she is communicating with Bob, whereas I'm in the middle, impersonating both. To both. This is what we call a man in the middle. That's a type of active attack. So I'm not only listening, but I'm sending, I'm altering, modifying the communication. Okay? Another physical example, which is very, very clear. If you want to jam a device, that's a type of active attack. مثلا, if you want to jam a drone or jam any wireless device, okay, jamming is some kind of a physical active attack. You are sending a wireless signal with very high power towards the device that uses a specific frequency range. So this device is not capable of communicating with any other device anymore. From the physical layer. And these attacks can be done in any layer, from the physical layer all the way to the application layer. Okay? The passive attacks can be with the, I'm just listening so that hopefully, I can read some message that's exposed, okay? Maybe as part of the communication, I can get any useful information, okay? Like some مثلا, طبعا I would be optimistic. I get مثلا user ID and password exposed as part of the communication. I would be very lucky, but could happen. Okay, and in many cases, passive attacks are done for traffic analysis. But traffic analysis, I'm not getting any exposed data, but I can actually get some properties of the communication. For example, just by the fact that you use fixed packets during the communication, that gives me some piece of information. It gives me some piece of information. Okay, so you have secure and hidden information, but in many communication, you cannot encrypt the header of the packet. Okay, so I can, in fact, get the header, read the fields, and get some information out of it. And traffic analysis here talks about the fact that you can try to guess the key. From reading the packet, sometimes you see that the packet has fixed length. You can read the header. You can get the length of the key from the header. So, okay, so all of a sudden you know exactly what you are targeting. So you have a key of, let's say, 64 bits. Okay, I have specific limited number of options. Okay, brute force, I can use brute force. Okay, just by listening and getting some information. So any communication, it has a certain level of leakage of information somehow. And in traffic analysis, that's a big area where attackers, they use some crypto analysis to try to guess some information based on the communication. And this is not to say that there are no mitigation strategies for this. There are some mitigation strategies for these types of attacks, in crypto analysis. Okay? There are some mitigation attacks, and, mitigation techniques, and we will talk about this. Okay? Passive attack. Active attacks, okay, as I said, they can come in any layer, okay, but in this recommendation documents, they categorize these active attacks into these. So Masquerade talks about the impersonation, which is the example that I just mentioned, where you can be in the middle of the communication and impersonate Alice to Bob and the other way around. So you can act as both Alice and Bob, okay? And in that case, both of them will communicate to you and give you more and more information. This is called a masquerade, or sometimes they call it man-in-the-middle attack. Or any kind of impersonation. So for example, I can get the user ID and password of a specific user. And then I can impersonate myself as if I'm that user and access the system illegitimately, and then I can get some information or modify some systems and data and so on, okay, under the access credentials of another person. This is what we call masquerade. Replay attack is one of the interesting attacks, really. So I'm not modifying the information. I'm not trying to get any information from the hidden encrypted data. I'm not doing any of this. All I'm doing is just to get the data, and then in future time instance, I'm just replaying the data again. Just by doing this, I'm modifying the communication. Okay? So the whole communication is going, and the packets are streamed. Okay? So all I'm doing is just to say, okay, I'm going to take this block of data, I'm going to replay the data. Okay? In many applications, this will corrupt the communication just by doing this. Okay? So I don't need any crypto analysis. I don't need anything. Another very interesting scenario, maybe many of you have heard about this, is to get access to cars using the replay attacks.
Yes.
You heard about this? With the key. Yeah, so many of the cars are keyless, and the cars, they rely on proximity. And this key is actually a wireless transmitter. So this key somehow needs to authenticate itself just by sending one message to the car to authenticate itself. Okay? So just by sending this message to the car, I can authenticate and the car opens. Okay? So I can use this replay attack by targeting a person. Person is walking in the mall, and all I need to do is just to try to capture the signal, because the key is sending these signals every now and then. So I can just capture this. I can send it with high power to another person who can just relay this to the car. The same message, relay to the car, and now I'm authenticated. I can open the car and I can steal.
Well, I was thinking, usually you have you change the frequency and that normal wireless thing, but in this case, do you send a beacon or something?
Yes, you send the whole thing is just to get this beacon. Okay, the whole thing is it needs some intelligence, of course, because you have to scan the frequency range to try to see where this beacon is. But all you need, just once you detect the beacon, all you need to do is just to replay this beacon in high power to another person closer to the car, who will again relay this to the car and use it for authentication. It's the same message.
Every car has a unique.
Yes. But I can just copy this message as is. I did not modify it. I know it's encrypted. I don't need to decrypt it. I can send it encrypted the way it is. Okay? So that's
in the 90s, it was actually what works for pseudo in North America. All cars had the exact same same. So once my car key will open your car, and there was a huge loss.
But even if it's different, replay attack can work in both ways. Yes, can work in both ways. So that's an interesting. But again, there are some mitigation mechanisms to protect against replay attack. So.
You can, I mean, sometimes the dealers will give you the box with the car as a gift, because when you park your car in the garage or near your apartment, your key is somewhere on the desk or something. They are on fire basically, that they come here to your house and they unlock your car in the middle of the night because they can reach your key.
Yes.
So these days in Europe you can get from the dealer box that kills the signal. During the night you leave the
okay. So that's yeah. So that's a physical mechanism to protect your car against stealing. Yeah. Uh, the simplest way is just again to ensure not by the integrity of the message itself, no, the integrity of the message tree. Okay? So you can ensure that just by simply specifying sequence number in each packet. It could be as easy as that. And that mitigates the replay attack. Because if you have a sequence number of 2000, if you replay the same packet again, it will have 2000, but I'm not at 2000, I'm at 3000. So I can easily mitigate. But this is given the fact that this sequence number is part of the encrypted data. In some applications, maybe the header is not encrypted, and that might be a problem. Okay? Right.
Sitting in the middle was very easy.
Yes, but
end of 90s, that was kind of fashion attack.
yeah, Muhammad, did you want to say something? But yes, 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 yes. Oh, okay. Right. Hmm. Right. Right. It's, yes, that's a very good point. Thank you for that. Yeah, so even blockchain has some issues when it comes to replay attacks where you can execute the same transaction twice, given that it's fast enough and you can fool the blockchain system. So the modification of messages, yeah, this is clear, of course. This is the straightforward way of affecting the communication or the data just by modifying the data. We talked about this. Or, as we said, by denial of service. Denial of service is also very clear, just sending illegitimate request to a specific system to bring it down. That's also but as simple as they are straightforward to understand, but they are very difficult to protect against. Okay. Um, so apart from FIPS and from ITU, the ISOC they have, of course, Ietf, internet. I don't know. The palm detection is not working well. So, Ietf, Internet Engineering Task Force. We have studied that in networking courses in undergrad. Ietf, they work on standards related to the internet. And of course, one of the aspects that they focus on is security services, of course. So they defined in RFC 4949, they defined security services as the processing and communication. Again, it's very similar to the other definition. Service provided by a system to give a specific kind of protection. By specific kind of protection here, we mean a specific kind of attacks, just like مثلا passive attacks or attacks that attack confidentiality or integrity or something like this. Okay. So again, in this document, the X800, we have these 5 security service categories or security service categories. Okay. Authentication, access control, data confidentiality, data integrity, and non-repudiation. So it's a slightly different way of defining the same security requirements defined by NIST, but here it's slightly different. Here they say authentication needs to be very fundamental in any system. Access control. So by authentication here, again, we said that authentication means that the person who is accessing this data or sending this data is really ensured that this is the same person that we know accessing this data. Access control here means that we need to provide all the privileges and access control restrictions to make sure that Amr is not accessing Muhammad's data, مثلا. Okay, and if you have like some user privilege, you cannot access systems or data on a very low level, like مثلا administrators or something like this. Okay, so that's what we mean by access control. And again, these are ensured by access lists, by some read-only or some restrictions on the file level, things like that. These are the mechanisms by which we provide access control. Data confidentiality and integrity, we talked about a lot. Non-repudiation here is again part of accountability. If a person sent a specific piece of data, he cannot deny later on and say, no, I didn't send it. So with the data itself, with each message, okay, we have to have some information that can trace back who sent this message. Okay? And if it ever happens that this person says, I didn't send this message, we say, no, you did send it, and that's the proof. Okay? Sometimes this proof is checked against some third party like notarization or some certificate authority that makes sure that when you send a message, it makes sure that the message is really sent by you and not anybody else. So if you ever deny, they say, no, you sent it, and that's the proof. Because the message itself somehow contains some information about your certificate. And it never happens that somebody else can send this message other than you. So, so these are all the services and some details about some categorization. Again, this is part of the X800. More details on each of these security services. So when it comes to authentication here, authentication is done on the connection level, and it's done on a specific message level. Okay, so when a person starts communication, we need to make sure that the person who is starting this communication is really the person who says he or she is, and every single message, okay, or if you try to send an email, or if you try to send a specific message, or if you try to initiate a specific transaction, we also need to make sure that this message has some authenticity. Okay? So therefore, we divide the authentication into peer entity authentication, and that's when it comes to connection-oriented communication. So if you have connection-oriented communication, so you initiate the connection, right? And then you send a stream of packets, and then you end the connection, right? So that's what happens. So in that case, we need some authentication at the beginning of the message, at the connection establishment. Okay, we need to authenticate each user to the other side. If it's peer-to-peer communication, each peer needs to authenticate itself to the other peer. Okay, and the other way around. So that's as part of that connection establishment. And then after the connection establishment, we have a multiple packets going from each peer to the other, right? So in every single message, we have to also make sure that this message is sent by this peer and not anyone else. Okay? So if anybody else tries to impersonate one of the peers, we should be able to identify that that's not the person that we expect to have this communication. So this is used for protecting against man-in-the-middle attack, and it's also used for non-repudiation, as we will see. So by identifying the person who is starting the connection and identifying the sender of the message in every message, we can make sure that there's no man-in-the-middle attack, okay, no impersonation, and we can also use that for non-repudiation. So if the sender says, no, I didn't send this message, we say, no, you sent it. In the message, we can trace back that you are the one who sent it and no one else. واضح كده؟ So data origin authentication is what we say that if you send مثلا an email or like one connectionless message, so you want to send a message to the server, okay? So you need to have a data origin authentication. So you need to authenticate yourself to the server, and that's usually by user ID and password, the simplest. You authenticate yourself once, you send the message, and then you finish. So this is what we call data origin authentication. Access control, the prevention of unauthorized use of resources, as we said, which is done by, as we said, like access lists, some file level restrictions, things like that. Data confidentiality is divided into 4 different things. Data confidentiality here is divided into, again, connection confidentiality. So the protection of all user data on a connection. And that's usually done by, again, during the connection establishment, I need to exchange مثلا the key, which is going to be used to conceal all the information during this connection or during this communication. Okay? So this is what we mean a connection confidentiality. So everything in this connection is concealed or hidden. واضح كده؟ واضح ولا any questions؟ تمام. Connectionless confidentiality, the protection of all user data in a single data block. يعني I want to send one data block, so I need to just secure that block. So it's not like a communication where you have a stream of packets. It's just one block that I send it, or like in blockchain, you have one certain block, you secure it, and that's it. Okay, so it's not a communication that will span for a long time. Service field confidentiality, that's an interesting one, the confidentiality or the concealment of selected fields. So, as we mentioned before, for some cases, I don't need to encrypt the entire packet. I can encrypt the data part, but not the header. As we will learn later on in IPsec, there are multiple modes in IPsec. If any of you has some knowledge about IPsec and the details, there are 2 modes for IPsec. One mode encrypts the data, but not the header. And that assumes the fact that intermediate network devices, they need to process the header without being able to decrypt the data. Okay? So this is what we call selective field confidentiality. I'm actually hiding specific part of the message, but not the entire message, because in some cases I may not be able to. And if I do that, this will not facilitate efficient communication. For example, if I encrypt the entire message, okay, and send it over the network, how would the router perform routing? How would the switch perform switching if they don't know the key? They cannot, right? So that's a trick. Well, can we do that by, by still hiding the whole message? If we have to do this, then we have to introduce another header. We'll learn all these tricks. But this is what we refer to as selective field confidentiality. A more interesting one is a traffic flow confidentiality. We use encryption. That's not traffic flow confidentiality. We use encryption, so we conceal the message. We do everything. But this will not protect against crypto analysis or traffic analysis. As we said, you encrypt everything. If you have a fixed size packet, you encrypt it. You have a fixed size packet that's encrypted, right? You send it over the channel. This will give information to the eavesdropper just by having the packet as fixed size. If the header is not encrypted, that's more information exposed. So I will get some information from here, I get some information from here. Somehow I can get the length of the key. I can use brute force, or I can use some intelligent techniques to guess what the key is. I can attack the entire communication, right? So I have, in addition to encryption, and that's why we said in many applications, encryption may not be enough. Okay? Encryption may not be enough. So in addition to the encryption, I need to provide some data in the packet, okay, which confuses the traffic analysis. For example, I can use, we will learn this in details later on, I can embed some dummy bits to just make the packet size variable. So any traffic analysis would be more confused. When I listen to the packet, when I listen to the communication, I see even the packet size is varying up and down, so I cannot get any information. Okay? More than this, just by the fact that the packet would go from one entity to another through the same route, that can give me more information.
So this topic of additional, this is done through padding field in the algorithm, right?
Yeah, this is not done by, what I mean is that this is not done by encryption. Encryption.
I understand, but what I'm saying is a technique.
Yes.
By using the padding field.
Yes, padding field, yes. Padding is actually part of confidentiality, okay, which is done outside the encryption or in addition to encryption. And sometimes we can mitigate or we can protect against traffic flow confidentiality by using different routes. So we learned in Network 1 course, we learned that routes, like we select best path based on the minimum cost. Due to security, sometimes we can use routes that are not the best, just by the fact that we want to confuse the attacker or the eavesdropper. Okay? So we can change the route every now and then just to confuse the eavesdropper. واضح كده؟ Yes, of course. Sometimes, this is part of the mechanism. Sometimes it's automated. Sometimes it's proactive. Sometimes, if you get some feeling during the communication that there might be some eavesdropping, okay, so you can try to use different routes to confuse. So these are details as part of the mechanism. That's what the developers should work on. Whether this traffic flow confidentiality can be done regularly, time-based, or event-based, based on whether or not there is some kind of attack going on. So
this is what they do with SDN, software-defined networking.
Yes, absolutely, yes. So that's what SDN is good for, really. SDN is very good for this because you can do this using software, virtualized network functions that can be as smart as you want. And they can really connect or merge the detection with some of these techniques, traffic flow, confidentiality, and so on and so forth, right? Because normal routers are used to have routes based on minimum cost, and that's it. But using SDNs, you can be as intelligent as well. The traffic flow, confidentiality, well, it's not really new. It's not really new, but definitely it's more recent compared to the other types of confidentiality, like connection confidentiality and whatnot. But definitely, yes, definitely what you are saying is perfectly correct. SDN has a lot to do with this. So data integrity, again, can, similar to the confidentiality, can also be, again, subcategorized into connection integrity with recovery. And when we say with recovery, that's another story. So just the fact that you ensure integrity, it doesn't mean that you can always recover if the data does not have integrity. Those are two different things. Okay? So detecting that the data is altered, that can be done by many mechanisms. For example, we will learn about digital signatures and hashing and so on. So you can use these mechanisms to easily detect whether the data was altered or not. Okay? But whether you are able to recover, which means correct the data, that's another thing. That's another thing. Sometimes this could be done by easily informing the sender that, okay, this data was modified, please send it again. That's the easiest way. Okay, but this will delay the communication. So, but the recovery is some other story. So there is connection integrity without recovery, as I said. So you just detect that the data was modified, but you don't do anything when it comes to recovery. So you don't actually recover the communication by informing the sender or anything. If the data is not integrated, you just don't accept it. You don't accept this data, and that's it. And again, selective field day connection integrity, similar to confidentiality. So you are focusing on integrity of part of the message, again, not the entire message. Or connectionless integrity. So you concern with the integrity of one single message. It's not the entire communication now. Okay? It's not the entire communication. So for example, replay attacks and so on can affect the integrity of the entire communication. But it does not affect the integrity of one single message. One single message still has integrity, right? But just by doing replay attacks, you affect the integrity of the communication, but not one single message. واضحة دي ولا واضح؟ Okay. Non-repudiation here talks about non-repudiation for the origin and non-repudiation for the destination. So if the origin sent a message, he cannot deny that he sent a message. If the receiver received the message, he cannot deny that he received the message, right? So, and this could be done, again, using some techniques in the message itself, and in many cases, it's done by notarization. You know the concept of notarization? There is a third party. When the sender sends the message, the third party or the notary can be informed, and this third party can make sure that this sender has really sent the message, and it actually confirms the certificate. When the receiver receives the message, also it has to inform the third party. So the third party is sitting in the middle and making sure that the communication is happening correctly. Okay? So non-repudiation is done by embedding or appending some hashing to the message to make sure that the identity of the sender is preserved in every message. That's one thing. But also the notary or the third party has to make sure that the origin has really sent the message and the destination has really received the message, so that non-repudiation is preserved in the entire communication. And again, all these protocols and details we will learn more and more as we go through the course. see some people watching so we will, okay. Okay, so in the next few slides, we reiterate on the security services that we talked about in the previous slide. So the previous slide was as the summary, and we are going to reiterate. So for example, authentication, we talked about peer entity authentication, where we have to secure the peer-to-peer communication end-to-end, which means that we have to authenticate each peer to the other, and we have to make sure that the entire communication is not altered in any way. And by altering here, I mean that no one is impersonating himself or herself in the position of any of the peers. Okay? That there is no man-in-the-middle attack. So that's what we mean by peer entity authentication. Data and origin authentication is to just make sure that the origin of this message is really the person who claims that he or she is. Okay? That's what we mean by the two types. Access control is the ability to limit and control the access to the host or to the systems and applications via communication links. It's to make sure that when you try to access a system, that you really have the privilege that you are supposed to have in order to access this machine or to access this data or to access this part of the system. To achieve access control, each entity trying to gain access must first be identified. So you either have to identify yourself through user ID and password, you have to identify yourself through a certificate, you have to identify yourself through physical tokens, any kind of method or mechanism to identify yourself, and based on that you get the privilege that you're supposed to have based on this identity. Data confidentiality here refers to the protection of transmitted data from passive attacks, okay? Based on broadcast service protections, all user data transmitted between two users over a period of time, they need to be concealed. So we need to exchange some key at the beginning of the communication, and this key can be used for encrypting the entire communication or all the messages in this communication. Or narrower forms of service that includes the protection of a single message. That it's not a connection oriented, it's not to secure the entire communication, but it's just a single message. So for example, if you want to send your email, so you want to send your email through a server, so you just need to conceal this information only by using certain some techniques that are specific for this type of communication, just by a single message, and you send it to the server. Or the protection of traffic flow, as we said, either through some routing, changing the route, or through some padding to the message to try to confuse the attacker or to the flow or traffic analysis. So again, data integrity can apply to a stream of message or can apply to a single message, as we said. By stream of messages, we can protect against altering the messages by replay attacks or any kind of a modification to the stream of the communication. For a single application, we have to use some kind of a hashing mechanisms to make sure that if the message itself is modified in any way, I can detect that the message has been modified. We use that through, like the simplest way is parity bits or some kind of hashing mechanism. We will study that. Or connection-oriented integrity, as we said, by ensuring that the communication is not modified or is not altered in any way. Okay. Non-repudiation is it prevent either the sender or the receiver from denying, transmitting, or receiving the message. And as we said, this is more often than not is done by some notarization. So some third party has to make sure that whenever the sender is sending a message, that really that sender is the one who sent the message. Whenever the receiver received the message, the receiver already received the message. So neither of them can deny later on, sending or receiving this message. Okay. Availability, the property of a system or a system resource being accessible or and usable upon demand by authorized system entity, and the availability of a service, one that protects a system to ensure its availability to address the security concerns raised by denial of service. So if a system or a resource can protect itself against the denial of service attack, which refers to illegitimate access of this data that would make the data not accessible just by sending requests to a system or to a data center or something like that, the system will become unusable or it will bring the whole system down, in which case it will not be usable or accessible by the legitimate users. And that's not good for any system to be not accessible. Okay? And we talked about how tricky this could be in some cases. For security mechanisms. So we talked about security services. We talked about confidentiality, non-repudiation, and so on. These are services. Here, these are mechanisms, and the service can use one or more of these mechanisms to achieve its objective. Okay, to provide the security service. And these security mechanisms, they can be specific security mechanisms. For example, mechanisms that target a specific layer. Okay, a mechanism that it's used in a specific location or a specific layer. Or it can be pervasive security mechanisms which does not necessarily target a specific layer. Okay, so we need to talk about the two types. So for example, encipherment. Encipherment here talks about encryption. Okay, so the use of mathematical algorithms to transform data into a form that's not readily readable by any attacker. So in that regard, we will learn different mechanisms. For example, DES, triple DES, AES, RC4. We'll learn all these encipherment mechanisms. We'll have an assignment about this. And then we'll talk about the properties, the limitations, the pros and cons for each of these mechanisms, and how they can be used in a specific layer to provide confidentiality or concealment to the information. So encipherment uses some kind of a key, as we all know. They use a key, whether this key is symmetric, which means that the same key exists at the sender and at the destination. So both of them, they agree on a specific key, and they use that for information concealment. We are pretty much familiar with that. Or this key could be different. So there is the public cryptography where the sender can use the public key, and the receiver uses private key, or the other way around. So each entity would have public key and private key. Again, we'll talk about the differences between these two types of encipherment, or two architectures for encipherment. What is the pros and cons for each one? Okay. Type. Digital signatures, we are going to talk about, again, we'll talk about cryptographic or some transformation, but this time, it's not to hide the message, it's to append something to the message. Okay? So the message itself will either be encrypted or not encrypted. Doesn't matter. Okay? But we will append some digital signature with the message. This digital signature will ensure two things. Will ensure that the message itself is not modified, and if it's modified, the digital signature will become invalid. Okay? Which indicates that the message has been modified, which serves what objective? Integrity, right? Which will provide integrity, right? The other thing is that digital signatures, sometimes we use cryptographic techniques to also embed the identity of the sender. They use that for what we call message authentication. Message authentication. Okay, so digital signatures can also be used for this type. Access control. We thought access control refers to group of mechanisms which provide access control service. So, in my opinion, it should not be a mechanism actually, because access control itself is a service, but it requires a bunch of mechanisms. For example, you need to provide access lists, or sometimes they call it revocation lists, or some kind of restrictions, or some kind of access privilege to certain users, or something like this. Or sometimes they provide some restrictions on the level of the data itself. So a read-only file, a write file, things like that. So these are all mechanisms to provide access control. Data integrity data integrity can be ensured by techniques like, or mechanisms like data signature. Okay, as we will see later. Authentication exchange. This can take also a bunch of different forms, either using user ID and password, either using, like for example, certificate, physical tokens that generate some dynamic IDs. Okay, that I'm not sure if any of you have used that. So sometimes in companies they distribute some physical tokens. It's a device. It's a device. At any point of time, the system will ask you what is the token that you have now, and this token changes a lot. Okay, so at any point of time, this token has a certain ID that identifies you in a way. So if you enter this ID in the system, given that it changes a lot, the system itself knows that it's you. Okay, so and it's a physical token. It's a device that you keep with you. I used to have it when I used to work in IBM in Canada. We used to have one. We use it for VPN access. Okay? Yeah. Yes. You seem like a highly secure guy. Okay, so traffic padding. We talked about traffic padding. We talked about padding, by the way, in network 1, right? But padding in network 1, it's not for security. We use it for aligning the size of the packets. Okay? We use it for packet alignment, very much. So it's just to put some dummy bits to align the packet in a certain length, right? But here, traffic padding is different. Traffic padding here is a mechanism which is used for security. Okay? So just by padding some bits with dynamic length, okay, use that to confuse the attacker. So the attacker doesn't feel that the packet has fixed length throughout the entire communication. Okay? So the attacker cannot really extract or leak some information from the communication in any way. Routing control, that's another mechanism. That again, routing control, traffic padding, encipherment, again, all of these are used for confidentiality of the communication. Routing can sometimes be used to also confuse the attacker. Because again, if the attacker sees that the packet is routed in the same path all over the entire communication, that can allow the attacker to relax and take her time or his time to try to apply some traffic analysis and get the key and so on and so forth. But if you are confusing the attacker by changing the route every now and then, this will confuse the attacker even more. Okay? Notarization, as I said, notarization is a mechanism where you have, as I said, like you have the sender, you have the receiver or the destination, and you have a certificate authority or some kind of a third party that whenever the sender sends anything, this will go to the certificate authority. Is that the person that really we think he is? Yes? Okay, so we can now make sure that he sent this message and he's really the person who says he is or she is, right? So whenever the receiver receives this message, it has to inform the certificate. So we know now that the receiver has indeed received the message. So this way we can embed ourselves in the communication and make sure that non-repudiation is preserved. Non-repudiation is preserved. That neither the sender nor the receiver can deny anything about sending or receiving the message. Pervasive security mechanisms, as I said, any of these mechanisms, usually they can be incorporated or applied in appropriate layer. Okay? This one is not applied in a certain layer. It talks about the entire system. It can be applied anywhere. Okay? In any layer, in any location in the system. Trusted functionality here that it's perceived to be correct with respect to some criteria as like established security policy as we all know, so we can apply like a policy for passwords. Okay, so that has nothing to do with a specific communication or a layer. This is like a security policy, so we can say that okay, passwords they apply this criteria. Okay, so anyone who accesses the system needs to have a password that complies with this criteria. So we can apply this criteria in any part of the system to ensure trusted functionality. Security label is something that we can, like watermark, or access a privilege of this file, that this file, for example, is read-only. That's a security label that we append with the data itself, okay, to ensure its security. So a file can be marked as read-only. That's a security label. We put it with the data itself. Or, for example, an image can be, we can have like some kind of a watermark or something that ensures that this data is valid. So that's what we refer to as security label. Okay. Event detection here means that you can detect any possibility of attack just by looking at the logs. So you can access the system logs, and from the logs you can say, oh, okay, so it seems that there was some type of attack. Okay? So this event can trigger some other procedures in the system. As we said, maybe we can use routing control based on event detection. So as I was telling one of the students here, that sometimes the traffic flow confidentiality can be triggered by events. Okay? So these events are detected, like sometimes from the logs, from any kind of integrity checks. So once you detect that the data is altered or there is some possibility of attack to the system from the logs or something, then you generate an event. This event has certain implications in terms of applying other techniques and mechanisms.
Does this event detection as a mechanism, does it dictate that security relevant events cannot be altered in the case of the attack?
No, by event detection here, I mean detecting of relevant events in the system.
No, I understand. But once when you record this
logs,
related event, does this mechanism describe that there should be protection over it, so there is integrity over it? Because usually what attacker will do when it compromises,
they will attack the logs.
Is going to first notify the logs.
They will attack the logs themselves. Yeah. Okay, yeah. That's of course that's a possibility, and that's what you referred to at the beginning. That even these kind of logs or audit trails, sometimes they call them audit trails. These are secure and they are stored securely, sometimes in blockchain or something like this, to make sure that these audit trails or these mechanisms for detecting events are not in fact modified or altered themselves. Because as he said, sometimes the attacker can attack the system and he or she knows that this will be recorded somehow in the logs, so he tries to, or she tries to alter the logs themselves to remove that event from the logs or something. So, of course, naturally, these types of logs needs to be secure as well. Security recovery deals with requests from a mechanism such as event handling and management functions and recovery actions. As we said, that detecting events is something and recovery from that event is another thing. So detecting integrity or detecting lack of integrity or attacks is possible, but sometimes recovery from the attacks may not be as easy as you think. So sometimes correcting the damage of the attack can be difficult. And sometimes irreversible. خلاص يعني the attack has happened. So all I need to know that detecting that this event happened or this attack happened, and somehow the maximum I could do is just to trace back to know who did it. But to recover from it, sometimes it's very hard. Yani the damage would be permanent, and sometimes it's hard to recover from. Okay. Yeah. So the last thing is this matrix is very nice because it gives us a whole perception of what service can be facilitated by what mechanism. So it kind of ties the services that we talked about to the mechanisms that we have summarized. Again, all these mechanisms, we'll talk about them in details in part 1, okay? And the services and protocols, we'll talk about them in part 2. But we can see, like, for example, digital signatures. We said that digital signature talk about some cryptographic part that gets appended to the message, right? So the message itself could be encrypted or could be exposed, whatever, but the digital signature, it's something that gets appended to the message, and it serves two things. It makes sure that the message itself is not modified, and it kind of identifies the sender or the person who's sending it. And that's why it actually can serve non-repudiation, right? It can serve data integrity, of course, okay? And it can serve the authentication. Makes sense? Both types of authentication, right? So it identifies the person, so it can be used for authentication, and it also can be used for non-repudiation. So if the person denies that he or she sent it, we say no. We can trace back and say, this is your signature on the document, so you cannot deny. Okay? So this matrix it really gives you the perception about the relationship between a service and how this service can be fulfilled or achieved using one or more of the mechanisms that we talked about. Okay? Inshallah, we'll talk next time about these attack services and service models and stuff. Okay? Later on.